It's really common to see machine learning poster child for GPUs, right? And machine learning has just caught fire, and what can you say? Very, very interesting. I tell my kids who are in college, do that. Right? It's a bright future. It's very hard to get the value of machine learning out back into production, get it operationalized, get your models not only just trained up on a set of data, but constantly retrained on new data that comes in. Some shops can do it, many can't. Many shops, the data scientists sit over here, they go to lunch together, they've got data that they've squirreled away, and they may do great data science. I'll give you an example for a large healthcare company. Large healthcare company, data scientists figured out that if they grabbed all of the doctor's notes from patient encounters and did some machine learning on it, they could flag where there was likely a bad diagnosis code. Okay? So if a doctor has put a bad diagnosis code, 57 instead of 75 as they fill out that silly form while they're trying to, do the electronic medical record, a very useful form, right? All sorts of bad things happen downstream. The wrong tests get ordered, maybe the actual condition is not treated, the patient could die, right? It's a terrible thing to have a wrong diagnosis code. So, data scientist, one guy, says, I bet I could flag that. I bet if I did natural language processing of the doctor's notes, I could flag it. If the notes said, mentioned the word blood sugar, and the diagnosis code they wrote was transposed, it wasn't diabetic, it was the other way. They just, they say, hey, what if we examine higher chance of it being a diabetic diagnosis if the word blood sugar appeared in the notes? Let me just check and see if it's a transposed for the diabetic condition, right? Succeeded in flagging a tremendous percentage, even if it's only a 5, 6, 10%, small. It's still hard work, right? Never made it into production. A phenomenal use case, right? That patient quality of care would have improved, and it never made it to production because of just the bureaucratic lethargy. He, the data scientist, was working on data kind of slipped to him because, it's very, people own data, that's right. And then he showed his result. It was very interesting, and people, it was just too hard operation to get this in production, okay? So that's just one story. That's what's being depicted over here, where data scientists commonly get data, right? They get it, they extract data somehow out of business systems, they do their work, and then what? How does it get back in? Now, one shop that I visited that I thought had a great approach to this and were very successful in getting data science work back into production. They did it by having different technical team members sit in pods. They had a data scientist sit with a developer and sit with a DevOps person. And these three people were jointly responsible. Data scientist comes up with something brilliant. Developer helps write the glue code so it can actually run against real data. DevOps person gets it deployed in production. And they can iterate. And this was a beautiful thing, right? It was very unusual. Now there's also some friction in the workplace because data scientists like to have lunch with the other data, right? But I thought that was a great approach to trying to address this problem. We are also looking at it through tooling. So, all right, let me see how many builds are on this slide. Okay, so by tooling, it gets to the question, why do data scientists, this is not a joke, it sounds like, why do data scientists like squirrel away their own data? I have no punchline for this, right? Because data is hard to get. Data is dirty. Most people spend, most data scientists spend most of their time, cleaning data, right? And once they've cleaned some data, right? There's a lot of reasons. With Kinetica, but one reason is data is just too slow, or it's too hard to get to, and I can't do stuff. This is some code that I'm going to run for in a second to try to make clear the point. If Kinetica is the database in this mix, the data scientist may find it's just as fast. It looks like they're running against local data. It's that fast. And if I can work on a 4 billion row data set, and I can do aggregations sub-second, and I can do group bys. I can do feature selection against the multi-billion row data set in real time or near real time. This is very interesting. It lessens the need for the data scientist to grab data just because they can run it locally. What this also means then, with this new framework that I'm describing and alluding to, if they can drop their libraries onto the database and have it called from the database, then there's a better chance that their code is closer to being operationalized, right? This still may not be a production system, but instead of them running a main program from a command line on a shell on their desktop, they could actually have it be invoked by the database. And I'm going to go more into that. But this is the point. This is the converge. The AI stuff is what's being added here. The BI is what we've had all along, which is that we've got these fast analytics in the database.